All right, so we will go ahead and get started. Thanks for everyone for joining us today. My name is Diane Lechner. I'm the VP of Sales here at Midland Scientific, and we're excited to partner with Environmental Express to discuss the Oakton benchtop portable offerings that they have here. I'm going to go ahead and introduce Marv, who's going to be the speaker today. And then for anyone that has any questions, if you want to send those through the chat or wait until the end, then we can go ahead and address those at that time. But quick introduction here, Marv Kaiser, as I mentioned, is going to be the speaker today. Marv graduated from the University of Illinois with a BS degree in analytical chemistry. He has spent much of his career training, marketing, sourcing, selling, and managing electrochemistry and spectroscopy product portfolios. Marv is an experienced speaker and has presented at numerous conferences, including PittCon, WEFTEC, and AWWA. Being known as the instrument guy, his experience ranges from simple pH testers to GCMS. His specialties include electrochemistry, water quality sampling, testing equipment, automated electrochemistry process instrumentation, automated sampling equipment, and laboratory testing equipment and chemicals. At Environmental Express, an Intellia Scientific company, Marv manages the global portfolio of electrochemistry and environmental products. So Marv, I will go ahead and hand it over to you. Thank you so much.
Thank you, Diane. That's quite the intro. Good morning, and thanks for attending today's Midland Scientific webinar. We'll be covering the new Environmental Express Oakton benchtop series, our 1500 and 2000 series. In addition, we'll look at selecting the correct meter, mating it with the correct sensor, and using the correct calibration solutions for your application. Thanks again for everybody for attending. Quick shameless plug here for Environmental Express.
I'm going to interrupt you real quick. There is sound issues? Cynthia, can you hear us? Can everyone else on the phone hear us? Okay. Go ahead, Mark. Sorry to interrupt you.
Oh, no worries. Okay, so again, a shameless plug for Environmental Express. In addition to electrochemistry products, we also offer sample collection, wet chemistry, metals analysis, inorganic and organic chromatography products, microbiology products, TCLP filtration products, and industrial hygiene, indoor air quality analysis. So first, I'd like to take a look at some of the applications and markets where electrochemistry products are used. The idea here is that there are hundreds and hundreds of different applications and uses for these instruments, with pH being the second most parameter measured behind temperature. It's measured in almost every industry and segment you can think of. I've displayed just a handful of applications in which electrochemistry products are used. We'll quickly go through the list, and specifically I'll start with EPA compliance. For a lot of folks who have to report, EPA compliance is critical, obviously, for your auditor or regulator. The three main parts of EPA compliance are a 0.01 resolution instrument, an instrument that has automatic temperature compensation circuitry, and then finally the ability to have 3 calibration points. Adding to that, pH is used just about in every segment you can think of: agriculture, mining, brewing, water and wastewater, semiconductor, chemical industry, obviously environmental, food processing. Some of the recent applications that I've talked to customers about would be pH of brine for canning, the connectivity of that brine, pH of pickled vegetables, pH of tomato paste and sauce, pH of skin, pH of plant tissue, pH of cement, sodium and calcium concentrations in that, fluoride in potable water, nitrates, phosphates in potable water as well. So obviously there's just hundreds and hundreds of possible applications for pH, conductivity, and dissolved oxygen measurement. So I'd like to start with just a quick, our last webinar with Midland, we talked about our new portable series. So I did want to do a quick review on this, just to let the participants know that we offer more than just benchtops. We offer a full electrochemistry line, testers, portables, benchtops, sensors, and calibration solutions. Specifically, I like to use the approach of good, better, best when offering up a product portfolio. So in this series, the 100 series is our entry-level instrument. As you can see, it's got a large display, shows both measured parameter and temperature, has a variety of different icons, including calibration, stability, battery status. We offer that 100 series in the pH model, the electrical conductance model, the pH and electrical conductance parameters, ion, and the dissolved oxygen parameter. In the middle, or our better series, is the 200 series. This features two specific models, the 250 and 260 models. Again, you can see that we've carried on the continuity of the displays here. It's a large display, has the measured and parameter and temperature, stability indicator. These will actually have an electrode status indicator, battery indicator as well. The main difference here is the 250 model has 500 data points, which are stored on an internal memory chip, and the 260 model has 1,000 data point memory that has a real-time clock and date. So it's GLP compliant. So when you download that data, it will have time and date stamp. For those folks building an audit trail, this is a key selection parameter in my mind. So that's the 260 model. We offer this series in pH, electrical conductance, pH and electrical conductance, dissolved oxygen, and PD, which is pH and dissolved oxygen. Finally, a touch on our 300 series. This is the best of our best. The 300 series is a smart sensor. It's truly a digital meter, and at the high end of our offering. The 300 series is a 0.001 instrument, has a 10,000 data points. It is GLP compliant with time and date stamp. We offer it in 3 channels, single, dual, and a triple channel. And the beauty of the smart sensors, as some of you may know, is that you just literally have to plug the sensor into the meter. The sensor has a chip built into the sensor holder or electrode head. When you replace these, you just replace the cartridge or the sensor at the base of that electrode. But the beauty is once you plug that sensor into the meter automatically knows, hey, this is a pH electrode, this is its serial number, this is the setup configuration that it was set up on, and the last calibration. You can even program in when the next calibration is due. Now, the 300 series, killer display on this instrument. It's a TFT color display. As you can tell, it's not a real good image here, but it's crystal clear. And again, the same continuity on the display. It has all the other icons that the 1 and 200 series have, but it's just an upgraded display. We offer this 300 series in the pH, electrical conductance, optical dissolved oxygen. PC is a dual channel, pH and electrical conductance. PD is pH and dissolved oxygen, again, optical DO there. And finally, the triple channel, which is pH, electrical conductance, and dissolved oxygen. The other beauty of that instrument is that you can configure that any way you'd like. If you want to use 3 optical DO sensors, you can plug 3 in, or if you wanted to plug any combination of those available sensors in, depending on how many channels that you have on the instrument. So next, I wanted to talk about sensors, specifically focusing on some pH sensors, just to give you an overall view of some of the sensors that are out there and that are available. First, starting with our epoxy body or polycarbonate, our single junction sensors on the far left of this slide, that actually incorporates a polycarbonate body. Fairly chemical resistance, but if you're going in, that's used for dilute solutions, potable water, any solutions that aren't super aggressive. So it's a great field probe, very durable. We sell a ton of these. They're very usable instrument. This first one happens to be a single junction polycarbonate. The next unit is a test tube style. So it's a small diameter, very long in length, can be used for test tubes, M&R tubes as well. And the last sensor in this grouping is a epoxy body. This happens to be a double junction electrode. Now this is for your more aggressive solutions. Epoxy is fairly chemically resistant and will hold up to most aggressive solutions. When in doubt, reach out to ask if that is compatible. The center grouping is the glass body electrodes. The first one is a spear tip electrode. The middle sensor is a large glass bulb with annular junction. It's a ceramic junction. That's a great sensor for low ionic strength solutions. You get enough electrolyte to leach into the solution or sample you're measuring to get a stable reading. And then finally, the third guy is also a glass electrode with a spear tip on it. Finally, the last group is the glass epoxy refillable electrodes. This first one is that low ionic activity solutions. It's got the large junction, the large glass bulb. It is a refillable unit. And then the last sensor on the right is a flushable electrode, pH electrode. It is refillable. You push on the top plunger and it will allow some of the electrolyte to leak into the sample that you're measuring. Again, this is great for, viscous samples, low ionic strength samples, and some of the hard to read mixtures that, may have some aromatics in there that, or some straight chain hydrocarbons that are going to cause issues with your measurement. So a couple things that I wanted to add in addition about pH electrodes. So your sealed electrodes are obviously the lower cost electrodes. The epoxy body, polycarbonate bodies are very durable, great for use out in the field. They normally have a shelf life of 6 to 12 months, depending on usage, depending on the application that they're seeing. Now, refillable, obviously, we have customers that have the refillable electrodes used that'll, 2, 3, 4, 5 years in lifespan before the reference finally gets attacked and is no longer stable. Well, one of the keys of this entire slide is the electrode soaker bottle here on the top right. All of our pH electrodes, ORP electrodes, are shipped and stored in a soaker bottle. This is key to the durability and the life of the electrode. Keeping the glass bulb and the liquid junction hydrated is key to the survival of that electrode. I'll talk a little bit more about that in a second. Did want to do a quick review of the advantages. Obviously, the glass body electrode is going to withstand higher temperatures. It's going to have better chemical compatibility. Hydrofluoric acid, HF, is probably the only thing that's going to really attack that glass electrode with a ceramic junction. But mitigates contamination and leakage. great repeatability, larger liquid junction on most, very easy maintenance. The key is there that the glass body electrodes are normally a laboratory electrode. The majority of them are refillable to give extra value and a longer life to that electrode. The epoxy body electrodes, as I had mentioned, high durability, great for field work. They're a lower cost instrument. All of our epoxy bodies have a protected bulb. The glass bulb are quite sensitive. So electrode types, some of the specialty combination electrodes that we offer. And by combination, I mean each of the electrodes has the reference part of the sensor built into it, as well as the measuring part of the sensor. I'll date myself that when I was first trained, we actually had a separate reference electrode and a separate measuring electrode. Nowadays, they're all combination electrodes with those two electrodes built into one unit. So glass bulb, high temperature electrodes, high sodium electrodes, glass sphere, flat face, all in one. That's a pH electrode with a built-in temperature sensor, and then single and double junction electrodes as well. The big difference here is a single junction. This is pictured kind of the lower center of this slide. As you can see, the glass bulb is what's doing the measurement. The liquid junction is where the electrolyte actually comes out into contact with your sample, as well as that glass bulb. When poisoning ions are introduced to pH electrodes, that's how they attack the electrode. They're actually will migrate across the junction and attack this little silver chloride reference tip. That is actually kind of the main stability point, I'll say, of this single junction electrode. And when the liquid junction either dries out because it's not stored in a soaker bottle or it's not properly hydrated, that's one of the key issues you'll see. The second one is poisoning. That's usually done by ions such as heavy metals, phosphates, sulfates, nitrates, amines, ammonia derivatives, and proteins. So to combat those solutions containing those poisoning ions, you want to upgrade to a double junction electrode. Now you'll see in the diagram on the lower right corner of this slide, the double junction design. You've got your single junction here where the electrolyte is essentially leaking out, mixing with your sample, coming into contact with the glass bulb, making a measurement. As those poisoning ions can get into the electrolyte, obviously they're big. The metals are big and positively charged. That'll attack the chloride part of the reference tip. The phosphates, sulfates, nitrates, big and negatively charged. That'll pull off the silver ions. So what happens is these poisoning ions work their way through the electrolyte and will try to attack the reference tip. The double junction actually has, we've got a couple designs with the glass capillary tube. Normally they're not on the lower, it's actually on the upper side of this capillary tube. And the poisoning ions have to go all the way up and around back to get to the reference. So anytime you're doing aggressive pH measurements and aggressive solutions, you want to upgrade to a double junction electrode. The electrode is going to be more stable. It's going to last longer. It's just better value for the money. Now let's talk about storage real quickly. As I mentioned, we offer our electrodes all with soaker bottles. The best solution to store it in is obviously a storage solution or electrolyte. That's the whole idea. Then there's little to no ion migration through that in the storage solution. So the electrolyte stays at a good strength, at its proper strength. Now, for short-term tap water with some, I'm out of the Chicago area, so we have water hardness due to this area is all built on limestone. So there's some sodium and calcium, magnesium ions in the water. They're not super aggressive against an electrode, so short-term tap water can be used. pH buffer could be used short-term. Never store your pH electrodes or ORP electrodes in distilled or deionized water. That will literally leach the electrolyte out of the electrode into the storage solution, and it'll go from a 3.8 molar, 4 molar down to less than 2, and that electrode will literally be done. So for cleaning, always important to rinse the electrode. You know, if you're measuring any solutions, but especially aggressive solutions, after each measurement, you want to have some tap water to quickly rinse the electrode off. The more exposure that electrode sees to aggressive solutions, the shorter its life's going to be. So rinse with tap water. If you've got oily or coating, coolants, any type of oil coating solutions, you want to use a soapy water. I always recommend Dawn dish soap, plug for them. It works fantastic at breaking down, coating type substances. Have had a long experience in the water wastewater industry, and you'll find a bottle of Dawn dish soap in just about any wastewater plant in the country because it's so good at cleaning the pH electrodes. So we also offer electrode storage solution. That's great for, if you're doing a protein based, some tris buffer kind of stuff. The cleaning solutions vary by manufacturer. It's great for grease removal, proteins, and other depositing solutions. So last, talk about calibration solutions. We offer a couple of types of pH buffers. The Oakton branded is our NIST traceable branded buffer. It does not include a NIST cert. The Oakton traceable branded buffer does include that NIST certification. So again, if you're having to provide an audit trail for a regulator auditor, this is key. You'll want to go with the NIST traceable or Oakton traceable product. The cert comes with it, and the auditor regulators will accept that usually without question. Secondly, wanted to touch on the variety of sizes. We try and offer pH buffers for every application. We first with the little 60 mil one shots. These happen to be the Oakton traceable variety. 120 mil bottles, 500 mil bottles. We offer the liter. We offer the 3.8 liter. We offer the foil pouches, which is great for outdoor stuff. So we offer a full buffer line, a full conductivity calibration line. I believe we have about 25 different conductivity standards, zero oxygen solution, electrode storage and cleaning solutions I already mentioned. And then we have a full complement of ion selective electrode refill kits to be used with our ISEs. So let's get into the meat of the presentation. Wanted to spend a little time initially and run through some of the options for electrodes, calibration solutions. I think that's key. The accuracy of your meter, whether it's a portable or a benchtop, is going to have two parts to it. The meter itself is very accurate. The sensor and how that sensor is calibrated, what solution is used to calibrate it, how many calibration points, that's really going to dictate your accuracy, your system accuracy, as well as the overall repeatability. So our new 1500, this is an entry-level benchtop, small footprint. These images really don't do it justice. The display is huge. Again, we tried to continue the continuity through our portables and benchtops with a smaller instrument, a larger display, and the same icons. Obviously, these guys don't have a battery indicator, but they will certainly have a stability and calibration indication. So 3 basic models in the 1500 series, the pH millivolt or PHORP, the electrical conductance, conductivity, TDS, resistivity, salinity, and temperature. And then finally, the PC 1500, which is a pH millivolt and all the electrical conductance parameters. Now, the sensors that we package, we offer this in 2 formats. A kit format that's going to have the meter, the electrode stand, the sensor, and the calibration solutions needed. In this case, it'd be pH buffers 4, 7, and 10. That would be the kit format. We also offer this as a meter and stand. In that case, if your customer's got a favorite pH electrode, maybe they have a high-end electrode that they really like to use, or it's an application specific electrode and they want to use that, by purchasing our ATC. We have a separate ATC probe for these meters. They could use that ATC and literally use any pH electrode with a BNC connector on it. Allows that customer that flexibility to choose and keep the sensors that they like or that they feel confident in. Now, what comes standard with the 1500 is an all-in-one, as I call it. It's got the pH combination electrode as well as a temperature element inside, so it'll measure pH and temperature. Conductivity is the same. It has the conductive plates as well as a temperature element built in. And then obviously the PC model uses one of each of those electrodes. So just a quick review. Again, this is an entry-level instrument. The pH is -2 to 16. It's a 0.01 resolution instrument, up to 5 calibration points in USA buffer or NIST buffer set, up to 6 with the DIN buffer set. Full ORP range, good accuracy, good repeatability, the temperature range, -22. That'd be interesting to measure because most solutions will be frozen at that point, but all the way up to 266 Fahrenheit. Key option here is that the temperature can be calibrated and adjusted if the temperature element has drifted at all. Offset and slope display, which is key for indicating the health of the electrode. I'll talk a little bit more about that down the road here, but that's a key thing you can quickly check. Another trick you can use is if you take a 7 buffer, go into millivolt mode, and you can measure 7 buffer is essentially 0 output for the sensor. If you go into that 7 buffer in millivolt mode, it'll give you a millivolt value. That's what's called offset. That'll quickly tell you if you didn't have the offset or slope indicator on your meter, what shape the sensor's in. Normally below 80%, it's time to refill the electrode if it's refillable. If it's a sealed electrode, unfortunately, it's time to replace it. So for conductivity, a 0 to 200 millisiemens, so it's a full range. It's got 5 different resolutions. It's got 5 different ranges. It's a technique that manufacturers use to really improve the overall accuracy. In this case, 0.6% full scale. Used to be, years ago, 2 and 3% full scale was a decent meter. Now it's got to be 1% or below. Reference temperature is adjustable. A temperature coefficient, the default on this is normally 2% per degree. That is adjustable. Obviously, your cell constants, a 0.1, a 1, and a 10. That'll cover all, electrical conductance ranges out there, up to 4 cal points. Now, auto cal, so this instrument is pre-programmed with 4 conductivity standards: 84 microsiemen, 1413, 12.88 millisiemen, and 111.8 millisiemen as well for the high end. Then you can do up to 5 manually. Resistivity, for those folks who are measuring ultra pure water, kind of a cool parameter to use. Resistivity is just the inverse of conductivity. TDS 0 to 100 parts per thousand, good resolution and accuracy on that. The TDS curves included EN 27888 is a DIN ISO 7888 curve, sodium chloride curve, the 442 curve. Myronell made that famous. That simulates naturally occurring water. So that's going to be, creeks, rivers, lakes. It's actually a 0.72, I believe, TDS factor, essentially. So the TDS factor is adjustable on those guys. And then finally, salinity range, excellent, 0 to 100 parts per thousand, good resolution, great accuracy, 2 salinity curves, seawater or sodium chloride, calibration option on that as well. Temperature, again, the key feature here is it's got a good range and it's got that cal option on the temperature. Most temperature sensors used nowadays in electrochemistry, especially lab electrochemistry, are thermistors. They're very fast, they're very durable. There's little drift usually. So it's a pretty stable temperature element. Okay, so included in both our 1500 and 2000 series for folks, obviously a US plug, but our power supply has 6 different plug combinations. You just slide the plug in to the converter and you're ready to go. For folks in the UK and Europe, we have those additional plugs that will help with flexibility in the power supply area. Okay, next let's talk about downloading. So the 1500 series has 1,000 data points, which can be downloaded via the software and the USB cable. The key feature here is that it is not GLP compliant, the 1500. While it does have memory and you can download it, it doesn't have a real-time clock in it, so there is no time and date stamp. If your customer needs that for their audit trail, they have to step up to the 2000 series, which will have 2000 data points with time and date stamp. Essentially, it's got that real-time clock built into it that allows the customer to build that audit trail. Software, super simple to use. As you can see, I've got the on the upper right of this screen, shows the mode and the data. A cool feature of the 1500 and the 2000 meters is that you can select auto log. It has the capability of automatically logging that data via the software, and then you can dump that into an Excel spreadsheet. The output is a CSV format, which is as soon as you save your data, it's now in that Excel format. So super easy to use, very intuitive. You can save your cal data, you can save your measured parameter data, and then as you can see this settings button up here at the top of the display, you can make some adjustments to the software. Again, very easy to use, very straightforward for those folks who are recording data. So quick overview of the 1500 series. We offer, again, the kit format, which is pictured here. You get the meter itself, the electrode stand, the sensor, the calibration solutions needed for that electrode, and the power supply with the 6 different plug configurations. Now, we also offer the 1500 series and our 2000 series with just the meter and electrode stand. That gives the customer flexibility to use different sensors. A little more challenging on the electrical conductance, because that's while it is a BNC, it does have a proprietary temperature curve. So you do need to use our sensor on that specific model. So those are the 3 basic kit formats: pH, electrical conductance, and PC. So before I get, I wanted to give a little quick overview of the buttons. These are technical buttons on this entry-level meter. But the key point here is the intuitiveness, the ease of use of this instrument. And how you tell that is what buttons are essentially on the keypad, right? This has a separate calibration button. It has a separate measurement button, a separate data button, separate mode button, and a separate setup button. The dot in between your up and down arrows, that's your enter button to confirm choices, and obviously your power button. But usually with instrumentation, when you have separate functional buttons like that, very easy to use, very intuitive. Many times you won't even have to look at the manual. And being a man, we do that quite often. Don't look at the manual until we get into trouble. And then once we do, we have to refer back to it. So I did want to give a quick overview of the programs and sub-programs in the 1500 instrument. The beauty of this is if you can understand and get the flow of the programs and sub-programs for the 1500 using the 2000 is exactly the same. The only difference would be there's some additional sub-programs to it. So quickly to go through some of the key basic programs, and there's 3 basic programs. You've got your measurement mode, lower left here. You would push the settings button that would put you into pH, up and down arrow to go to data, and then up and down arrow again to go to general. So we'll take a look at real quickly at drill down into some of the programs. I think it's important that users understand their instrument and be able to navigate these programs and sub-programs easily. That's when I talk to customers, which I do all the time, that's one of their biggest challenges. They have trouble navigating through these programs. So next, again, from the pH on the last page, you'd hit the enter button. You go in and pick your buffer set, whether it's USA, NIST, or DIN. And then the reverse out of that, you just hit the settings button. From the buffer sub-program, you can go up and clear data. The default settings here are in gray, USA buffer, no to clearing data. The data button, again, enter, you can log. This is where you set up your auto log. You can set that to seconds and how long the duration is in between accepting readings. And again, the key here is the settings button brings you back out. Up arrow and to set up your print if you want to print values, and then up arrow again into your data, clear data, or save data. The defaults are listed right here: no to clearing data, no to printing, and then you can do your auto adjust. And then finally, the general program. Now this allows you to get into stability mode. You can set up with auto stable, auto hold, or real-time measurements. Again, you back out of this using the settings key. From there, you can go to auto shutoff. You can set both the 1500 and the 2000 have that ability from 1 to 30 minutes to shut the instrument off. Another up, you go into temperature selection, centigrade or Fahrenheit. another up, and you go to factory reset. So again, here's the default settings in gray. Pretty straightforward and easy to use. So this gives a quick look at from your measurement screen in conductivity. You can drill into the conductivity and net subprograms, go up to TDS, go up to salinity, go up to data, go up to general. The key here is parameters or measurement mode, data, and general. Those are the three main paths into the program of this instrument. Very easy to follow. So from conductivity, you push the enter button, you go into pick your cell constant. You set that up. Again, the settings button brings you right back out. You can go up and set your units. You can go up for auto calibration. Again, that auto calibration, that are the pre-programmed conductivity standards that I mentioned before, the 84 microsiemen, the 1413, the 12.88 millisiemen, and the 111.8 millisiemen standards. A little bit more in the conductivity and TDS. Here's your temperature coefficient. Here's your reference temperature, you can, which is adjustable, and then your data or calibration clearing capabilities. Again, enter with the enter button, exit using the settings button. Pretty straightforward. TDS, again, you can set up your curve. You can pick the curve, the linear curve, the 0.5 curve. From the you can jump up and do units, obviously, with this. With the TDS curve you pick, you have to go to linearity and then up to the 442 curve, or the DIN EN 7888 curve, or the sodium chloride curve. Salinity, same type of setup. Enter button, you can pick your units. Up and down, you can go into sodium chloride curve or seawater curve. Up again, you can clear calibration. That clear calibration is great if you have you error out on a calibration. You can quickly clear that recent calibration and go back to perform a new calibration. So moving on to the 2000 series meters. We'll cover this fairly quickly. In the 1500, we had the pH millivolt, the electrical conductance, and the PC. In the 2000 series, we have our full suite of parameters: pH millivolt, electrical conductance, PC, ion, dissolved oxygen, BOD, and PD, which is pH and DO. Some of the upgrades on the 2000 model, AutoCal standards. It's got the real-time clock. It's got 2,000 data points. These are, again, can be downloaded easily via the complementary software and cable, and the time and date stamp for building an audit trail. It's got the auto data log, which is similar. Password protect, that's a different feature on a 2000. Software, of course, is upgradable. Adjustable time off from 1 to 30 minutes, and the temperature calibration. So an overview of the features on the 2000. This is what I would consider a research grade instrument. It has 0.001 resolution. It's got a small footprint for the busy lab desks, sleek design, auto stable, auto hold, auto calibration, auto data log. It's got the auto time off, shut off rather. So it's got that whole suite of the automatic functions that you can set up, or you can turn off if you don't like them. Internal memory, as I mentioned, download capabilities, 3-year warranty. Again, we offer that in the kit format. That includes the meter, the power supply, the electrode stand, the sensor to be used with the kit, and the calibration standards. So I talked a little bit about the electrode indicator, some of the cool features of the 2000 series. Obviously, it's got the pH slope indicator, as I mentioned. Anything below 80%, you need to refresh the electrolyte inside a refillable electrode, or unfortunately, if it's a sealed electrode, it's probably time to buy a new one. Very good from 85 to 95, 95% and above. That's a killer electrode. That's brand new. Some of the other cool features on the ion meter, it also gives slope reading. The conductivity and salinity gives you a cal factor. So it tells you pretty much when you need to recalibrate the instrument, or in some cases, if you're going into an oxidizing solution and your plates on your conductivity cells start to oxidize, you may have to clean them and recalibrate. And then DO as well. Really cool feature that gives you some insight into what the sensor status is, whether it's pH, ion, electrical conductance, or DO. All right, so take a look at the range on the 2000 series. It's a -2 to 20. As I mentioned, 0.001 resolution max. The accuracy on this instrument is killer, 0.003 plus or minus pH. Now, in addition to the accuracy of the instrument and sensor, you have to add on the accuracy of your buffer. So that's where buffer is a key part of the overall system accuracy. You literally add those two values together, that gives you the system accuracy. Expanded buffer groups in this guy, USA, NIST, NIST2, DIN, as well as custom. Up to 5 calibration points on the USA, NIST, and NIST2, up to 6 on the DIN and custom. Offset and slope display, full range for the ORP. And then this gives you some insight to the different buffer groups. Pretty common. We carry all of these, USA NIST1, NIST2, but not all the DIN. So more buffer groups, shows the segment and slopes, allows for direct ORP calibration. And then we'll quickly touch on the electrical conductance, 0 to 2000 millisiemens. So this is a full range electrical conductance measurement. Any conductivity measurement you could think of, you can do with this instrument. It's got excellent accuracy, again, plus or minus 0.6%, 1.5% full scale, above 18 millisiemen. Still, again, excellent accuracy. Reference temperature is adjustable, temperature coefficient, cell constant, up to 4 cal points, 5 points manually. Resistivity 0 to 20 mega ohms. TDS is 0 to 100 grams per liter. And again, these are all auto ranging with good resolution in each of the ranges. TDS curves, as I mentioned, the EN curve, that's the DIN curve, 7888. The 442 curve for naturally occurring water, sodium chloride, or linear, those all being adjustable. And then the ranges of some of the cells. Obviously, the conductivity cells from different manufacturers have some different ranges. A 0.1 is going to do your real low end measurements. Now, some folks' cells go up to 20 to 40 microsiemen with that 0.1 cell. Some will go up much higher. In this case, we'll actually go up to millisiemen range. The one cell constant of 1.0, that's your good average everyday cell. That won't do really good at the super low end, but it will cover, 85, 90% of the measurements. And then your your K equals 10 cell, that's really for your seawater and super high end measurements. So 0.1, a 1.0, and a 10. Those are very common. All right, that ends my presentation for today. So we'll open it up for questions.
So thank you very much. This is Diane. We did have one question come through during the presentation, and it was, it says, why are the pH solutions not colored as one normally would see?
Yeah, so we offer both colored and non-colored. You'd be surprised at the number of customers who request clear buffer solutions specifically, but we do offer both.
Any other questions for anyone on the call? And I did want to let everyone know we are recording the session, and so we will send that out to everyone who registered, so you'll have this as a point of reference afterwards. Another question here is the 2000 model has LIMS connectivity, or does that model have LIMS connectivity?
No, it does not. It does have RS-232 output, but it's specifically driven so that you can use, the Excel spreadsheet with your data output. It's not LIMS compatible, but that's a great idea. I will definitely take that to the engineers.
Thank you.
Okay, any other questions?
Doesn't look like it. Marv, I just want to say thank you so much for the presentation today. This is a lot of great information, and definitely we'll share it with everyone who participated. And then obviously if we get any questions afterwards, we'll make sure to funnel those your way too.
Great. I appreciate everyone attending, and thanks so much.
Thanks everyone. Have a wonderful day.